Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. This is episode 52 and for this episode, I will be covering the topic about comparing rational numbers. In our previous episode, we studied what rational numbers are. So this time, we will compare which number is smaller or bigger using the absolute value of the numbers. This episode has two parts. In the first part, I will discuss the topic absolute value. This is a new concept, so make sure to focus so you'll be able to understand easily. In the second part, we will compare rational numbers. This is the first part of this episode, and I will discuss absolute value. When we say absolute value, this is the distance of a number from the origin in a number line. The symbol for absolute value is this symbol. What is a number line? A number line has an origin or the center of the number line. To the right of the origin are positive numbers. To the left are negative numbers. This is positive 1, positive 2, positive 3. This is negative 1, negative 2, negative 3. This is a number line. Okay, what does it mean by absolute value or the distance of a number from the origin in a number line? Let's give an example. Let's find the absolute value of positive 3 and absolute value of negative 3. First thing we need to do is, we need to locate where is positive 3 and negative 3 in the number line. Okay, let's start with absolute value of positive 3. In our number line, positive 3 is this point. Now, what is the distance of positive 3 from the origin? Okay, 1, 2, 3. So the answer is 3. Absolute value of positive 3 is 3. How about negative 3 or absolute value of negative 3? In our number line, negative 3 is this point. What is the distance from the origin to negative 3? 1, 2, 3. So the answer is 3. That means whether the number is positive or negative, absolute values are always positive. Remember, absolute value, this is the distance of a number from the origin in a number line. There is no negative distance. That's why absolute values are always positive. Another example, let's find the absolute value of positive 4, negative 4, positive 1 half, and negative 1 half. Let's start with absolute value of positive 4. In our number line, positive 4 is here. What is the distance from the origin to positive 4? 1, 2, 3, 4. So the answer is 4. How about absolute value of negative 4? In our number line, negative 4 is here. So from the origin to negative 4, the distance is 1, 2, 3, 4. So the answer is 4. Let's move on to number 3. What is the absolute value of positive 1 half? We can put all rational numbers on a number line, not only integers. That means we can also put fractions or 1 half in the number line. Okay, positive 1 half is somewhere between 0 and 1. So let's divide this by 2. So 1 half is this point. So this is positive 1 half. What is the absolute value of positive 1 half or the distance from this point or from the origin to 1 half? The answer is 1 half. How about absolute value of negative 1 half? Negative 1 half is between 0 and negative 1. So divide this by 2. This is negative 1 half. So what is the distance from the origin to negative 1 half? The answer is 1 half. Okay, we can also put decimal numbers on a number line, but we need to convert decimal numbers to fractions before putting. Okay, this time, my question is, does absolute value always have two numbers? The answer is no. Okay, students think absolute values numbers are always two, positive and negative numbers. But it's not always the same case. Okay, I will explain, or let's check. How many numbers are absolute value of A? Okay, number one, absolute value of A is greater than 0. Greater than 0, it means the number is positive number. Okay, so let's give an example. Let's say A is 3. So in the number line, this is the origin or 0. This is positive 3. This is negative 3. So how many numbers are absolute value of 3? We have two numbers, negative and positive numbers. So there are two numbers. How about if A or absolute value of A is equal to 0? Okay, this is 0. We don't have positive 0. We don't have negative 0. 0 is just 0. So how many numbers or how many number? We only have one number, and that is 0. So it means absolute values numbers are not always positive and negative numbers. It depends on the range of the numbers. Okay, this time let's answer the following problems. The first problem is, when representing the following numbers on a number line, which number is closest to the origin? When we say closest to the origin, nearest to the center. Or we can say also what number, or we can get, or we will get the smallest absolute value. We'll find the number that has the smallest absolute value. So get the absolute value of each number. Absolute value of negative 2 over 3 is 2 over 3. This is 3 over 4. 1.2, 1, and this negative, no, not negative. Absolute value of negative 3 over 2 is 3 over 2. 1.2, 1, and 3 over 2, these numbers are 1 or more than 1. So let's exclude these three numbers. Remember, we're looking for the number closest to the origin. Okay, we have here 2 over 3 and 3 over 4. To find which is smaller, we need to make their denominators the same so we can compare faster. So we multiply this by 4, this is by 4, this is by 3, 3. So we have 8 over 12, and this is 9 over 12. Okay, 8 over 12 is less than or smaller than 9 over 12. So the answer to this problem is letter A. Okay, let's have the next problem. When representing two numbers on a number line, both having equal absolute values but opposite signs, and the distance between the 2 points is said to be 5 over 4. What are the two numbers that satisfy this condition? Okay, two numbers on a number line, both having equal absolute values but opposite signs. Opposite signs, that means positive and negative numbers. Okay, the distance between the 2 points is said to be 5 over 4. If this is our number line, okay, this is the center or the origin. We have here the positive number and the negative number. Okay, the distance between the 2 points is said to be 5 over 4. So from here to this point, distance is 5 over 4. Okay, it means from here to here and from this point to this point, equal size or distance. So what are the two numbers that will satisfy this condition? So what we need to do is divide 5 over 4 by 2. So this is 5 over 4 times 1/2. And the answer is, we have 5 over 8. Positive and negative numbers. So we have negative 5 over 8 and positive 5 over 8. So these are the two numbers. This is the second part of this episode, and I will discuss how to compare rational numbers. Comparing numbers is telling which one is smaller or larger. To represent the numbers on a number line, the numbers to the right is greater than the numbers to the left. That means, as we move to the right, number increases. But as we move to the left, number decreases. Example, 0 is less than positive 1 because 0 is at the left of positive 1. Negative 2 is greater than or larger than negative 3 because negative 2 is at the right of negative 3. In positive numbers, the bigger the absolute value, the greater the number. In negative numbers, the larger the absolute value, the smaller the number. These are the positive numbers and these are the negative numbers in this number line. Absolute value of positive 1 is 1, positive 2 is 2, positive 3 is 3, positive 4 is 4. Absolute value of negative 1 is 1, negative 2 is 2, negative 3 is 3, negative 4 is 4. For positive numbers, the larger the absolute value, the larger the number. Example, absolute value of positive 3 is 3, positive 4 is 4. 4 is larger than 3. That's why number 4 is larger than number 3. For negative numbers, the larger the absolute value, the smaller the number. Example, negative 4's absolute value is 4, negative 3 absolute value is 3. 4 is larger than 3. That means negative 4 is smaller than negative 3. Okay, this time, let's answer the following problems. The first problem is, how many integers between the two rational numbers, negative 7 over 4 and 5 over 2? Remember, integers are exact whole numbers, positive and negative exact whole numbers, including 0. So we will find how many integers between these two rational numbers. First thing we need to do is, we will convert these two rational numbers to mixed fraction. Okay, let's start with negative 7 over 4. To mixed fraction, this is negative 1 and 3 over 4. 5 over 2, convert to mixed fraction. This is 2 and 1/2. Okay, this time, let's draw a number line. So this is the center or the origin. This is positive 1, positive 2, positive 3. Negative 1, negative 2, negative 3. Okay, let's put negative 1 and 3 over 4 in this number line. So this point is somewhere here. So this is negative 1 and 3 over 4. How about 2 and 1/2? It's between 2 and 3, so this point. So this is 2 and 1/2. How many integers between these two numbers? So we have negative 1, 0 is also an integer, positive 1, and 2. So there are 4 integers between these two rational numbers. Okay, let's have the second problem. Which among these 5 pairs of rational numbers has a different inequality sign? Let's check the first pair. Absolute value of negative 1.3 and number 1.2. Absolute value of negative 1.3 is 1.3. So 1.3 is greater than 1.2. How about letter B? 4 over 5 and 5 over 6. So we can compare these two fractions easier. Let's make their denominators the same. So this is times 6. This is times 6. This is times 5. This is times 5. So 24 over 30. And this is 25, okay, over 30. So same denominators, same positive numbers, but 24 over 30 is less than 25 over 30. How about letter C? Negative 3 and negative 7 over 2. Let's convert negative 7 over 2 or 7 over 2 to decimal number. This is negative 3.5. Okay, both numbers are negative, but negative 3 is greater than negative 3.5. If we will get the absolute value of negative 3, it's positive 3. Absolute value of negative 3.5 is positive 3.5. So, the bigger the absolute value, that means the smaller the number. That's why negative 3 is greater than negative 3.5. Okay, let's have letter D, negative 4 and negative 4.1. So both negative numbers. But negative 4 is, okay, greater than negative 4.1. How about letter E? Absolute value of negative 2 over 3 and absolute value of negative 1/2. Absolute value of negative 2 over 3 is positive 2 over 3 or 2 over 3. Negative 1/2, absolute value is 1/2. To compare these two fractions easier, okay, let's make the denominators the same. So 3 times 2, this is times 2. 2 times 3 times 3. Okay, this is 4 over 6. This is 3 over 6. So same denominators, but 4 over 6 is greater than 3 over 6. So which among these 5 pairs has different inequality sign? This is greater than, less than, greater than, greater than, greater than. So the answer is letter B. Okay, let's answer this last problem. How many non-integer rational numbers with denominator 6 are between two rational numbers, negative 3 over 2 and positive 2 over 3? Okay, when we say non-integer rational numbers, this means irrational numbers. Okay, what or how many irrational numbers with denominator 6 are between these two numbers? Okay, first thing we need to do is we need to make the denominators the same, or the denominator must be 6. So negative 3 over 2 and positive 2 over 3. So this is times 3 times 3 times 2 times 2. So we have negative 9 over 6 and this is 4 over 6. So same denominator 6. Okay, this time we will find how many irrational numbers between these two rational numbers. Okay, so let's write this way. Negative 9 over 6 and positive 4 over 6. Okay, so negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. Let's move this. Okay, 0, 1, 2, 3, and 4 over 6. Okay, denominators are the same, 6. Okay, negative 8 over 6, negative 7 over 6, and so on. But negative 6 over 6. This is negative 1. This is an integer, so we will not include this one. 0 over 6 is 0. 0 is also an integer. So what are the irrational numbers here? Negative 8 over 6, negative 7, negative 5. So we have negative 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 non-integer rational numbers between these two numbers.